All right, part two of composition of functions, day one. Um, when we're talking about the domain and range of a composition of functions, it actually becomes pretty complicated because if we think, you know, of the skip function, we think of whatever comes out of this becomes the input for the new function. That we could have um, holes in the domain of f, and we could have holes in the range of g, and thinking of the function altogether as far as the holes of the individual functions, it's actually quite complicated. So what we're going to do here is we're going to calculate the the formula. We're going to find the skip function and look at it. And we'll see that in the next example. So we'll actually just treat that as a new function and think about the domain and range of the new function, which actually, as we'll see, will be quite challenging at times because we end up with functions that we've never seen before, graphically anyway. So here we go. We've got two parent functions, right? And the reciprocal function and the square root function that's been moved left to, and we could graph these if we want to, but all we're asked for is a calculation here, so no problem. We know that f at g at -3. We could calculate f at g at x in general, but we know that this is just that, right? G is the inside function. What's g at -3? Well, we kind of got to do that calculation, I guess. G at -3, whether I do it in here or in the margin, I'm just going to do it in the margin. G at -3. Notice that if I was thinking about -3, it's not in the domain of f at all. But as it turns out, after we do part g to it, we do the g function to it. This is fine. It's not anything very pleasant to deal with because I end up with fractions. But where the x is now, the square root of -1/3 plus 2, I can actually calculate that if I wanted to, and it's some value. Have I got it here somewhere? Well, it's the square root of -1/3 plus 2, which is 1 2/3, and I don't really care what that is. That's some value that we can actually calculate. But the point is that we could do that. If we put in -3 into f straight off, we couldn't. But that one was okay. So f composed with g, this is the general one now. I suppose we could have done that first. Equals f at g at x. G at x is just the 1/x function. And then in f, where I had an x becomes the new function 1/x, and this is, and we see in here -1/3. This was okay for x to be -3 in there, and we could have actually done this type of question first. In fact, I'm going to do that with part C, so you can see how that works. Notice that in part C, again, we've got one. Oh, 0. I can't have 0, but we'll see that absolutely you can. I'm going to do part D first, just to show you that it doesn't matter which order you do them in, whether you find the function and then do the calculation, or do it the other way. F is the inside function here, and so I get g at this expression. F at x is square root of x plus 2. And in g, where the x was, I put in this new inside expression, and then there is my skip function. And notice I did d first because now I want to show you how I could go back and calculate individual values if I wanted to from the skip function. 1/2. And again, in the skip function, the composition of functions, putting a 0 in there was no problem at all, even though I couldn't have put it into to g. We'll see here that the domain and range are actually fairly challenging. The domain and range of G composed with F, so that's, I'm going to move this stuff down so I've got some room. Actually, I'm going to use a new page. So my skip function, G composed with F, was 1 over the square root of x plus 2, right? So the domain I think of is what x values are allowed or not allowed, because I can't think of the graph of this because I've never seen a function like this. I don't know what the graph looks like. We'll actually turn to the graphing calculator to help us out with some of these questions. But let's just think about this. What are some restricted values for this x? Well, we see that we know we can't take the square root of a negative number. So one restriction would be x has to be greater than or equal to -2. Otherwise, I'm taking the square root of a negative number. And in fact, that was one of the restrictions on the function f. But also, I see that I can't divide by 0, right? This whole thing here can't be 0. So what value will be would give me the bottom being 0? Well, x can't be -2. And if I combine these two restrictions, I end up with my domain. X has got to be greater than -2. And so that means this function must be defined only for x is greater than -2, whatever it happens to be. Now, what about the range? What type of values am I going to get out of this function? Well, certainly I can see that I'm only going to get positive values, right? This bottom's never going to be negative. And it's never going to be 0 because I never have anything, you know, on the top to make this 0. This is never going to be, it's going to get close because as x gets very, very, very large, the bottom gets very large. So as x goes to infinity, this goes to infinity, and then the entire thing, the bottom gets 1 over a really, really big number, goes to 0. So this is there's going to be an asymptote in this. But y is never going to be equal to 0. And in fact, it's always going to be positive. So if I think of this, this must be the domain. And I just thought about that, the numbers here, how the numbers were behaving. A perfectly acceptable solution in homework tomorrow in class would be for you to go over, grab a graphing calculator, and notice I've got my graphs, and 1 over y1 is 1 over the square root of x plus 2. And if I graph this, hopefully got some decent values, I see that x has got to be greater than 2. And it looks like that it gets cut off, but that's just the way that this graphs it. That is it possible for y to be you know, like 6 or 12 or something like that? In fact, yes, because if x gets close to -2, y is going to get close to infinity. So this should actually continue on forever, but I can see my asymptote that I expected. So a perfectly acceptable way to do this would be to graph it and then just see what's happening. Okay, and in fact, you know, I see it's 3.16, but if I were to put in a value of -1.99, x is getting close to 2, then I will get an output. It says 10. Okay, what about -1.99? 1.9999. Yep, it is going up to positive infinity. So the graphing calculator, the way it calculates it, will cut it off, but it certainly is a vertical asymptote as well. Now, what about the other one? So that was what? That was part E? Yeah, that was part E. Part F, we'll see, is even more challenging. It's even more funsies. And that was 1 over x plus 2. In this one, well, certainly we see for the domain, it's a little smaller here, the domain, I can see x can't be 0 because I don't want to divide by a negative, right? Also, I see that this 1 over square root of x has to be greater than negative 2. Otherwise, I'm going to be taking the square root of negative. Now, if you just sort of guess and check in here, you can say, well, what's the value of x that will allow that to be greater than negative 2? Well, if it was 1, yeah, that's okay. Actually, 1... one's going to be okay if I put it in this, because then I take the square root of a positive number. And in fact, if I think of my domain here, I said that 0 is not allowed. Any positive number, 1, 2, 3, then I'm going to be taking the square root of a positive. These are all fine. Now, what about negatives? So for instance, if x is negative 1, if x is negative 1, now let me put negative 1 out here somewhere. X is negative 1, then this would be 1 over negative 1, 2 plus negative 1. Yeah, that's okay. Negative 1's okay. And in fact, any numbers out this way, negative 2 would be fine, because that would give me a negative fraction that's not bigger than 2. Well, what's the cutoff point then where there are numbers that are not allowed? Well, guessing and checking will lead you to negative a half, right? Because when I flip negative a half, that's going to be the equal point for when x is equal to negative 2. So x has actually got to be less than negative a half. Because if x is less than negative a half, this is negative a half here, then when I flip that number, 1 over x, it's going to be smaller than positive 2. So all of these numbers in here, all these negative fractions, not allowed. So it looks like we have a little hole in our domain. So if I think of the domain, what is it going to be? And this is kind of all rough work here. Let's put this together over here. The domain is x has got to be less than or equal to negative a half, or, and this is kind of like the set or, this is set union. And I could have just put a comma, that would have worked too. X is greater than 0, right? We said x can't be equal to 0. Now what about the range? And this is actually interesting as well. The range, I can see the output is always going to be positive because it's coming out of a square root, right? So can it be always going to be positive, but can it be equal to 0? Well, yeah, it can be equal to 0 because if x is negative a half, I flip negative a half, that's the square root of 0, which is allowed. So it can be 0. Now, what's weird is this inside thing here, that can never be 0, right? That's never going to be 0. So I'm never going to have a value of the square root of 2, right? This thing's never 0. It's kind of like the output for this is never 0. So also, I think of y is never going to be the square root of 2 because this thing here is never going to be 0. So this is going to look like a very interesting graph. I'm going to have a hole in my domain where there's no values defined. I'm going to have only positive and then some sort of asymptote. It feels like, you know, as x gets close to positive infinity, then y is going to get close to the square root of 2 because this is getting close to 0. Y goes to negative infinity. This is going to become a really small negative fraction, and y is going to get close to the square root of 2. So I'm going to have an asymptote. There's your domain and range. Let's look at the graph. Okay, that was the other one. So here's my composition of function 1 over x is y2 there, and then I'm going to graph this and see what she looks like. Notice there's my little gap in the domain from negative a half to 0, where it's not allowed, and look at the range is always all positive numbers except for the square root of 2. Do you think that's probably the square root of 2? Well, let's just check it out. Let's put in the square root of 2 there to see if indeed that's the asymptote. And there it is, the square root of 2. This graph is never going to be equal to the square root of 2. Now that's some pretty fancy thinking as far as the domain and range is concerned. Completely acceptable for you to grab a graphing calculator, pound that in there, then have a look at the graph and state the domain and range. Okay? All right. What an example. Good luck with the homework, folks. Composition of functions, day one.